We're going to start our examination of the idea of a limit with not a definition. The limit of a function at a point is the value, and when we say value, we mean y value, that the function would be at that point if it could be. To understand what I'm saying here, let's consider f of x is equal to x squared minus 2x minus 15 over x minus 5. Now this is a rational function, and we can see that the domain is the set of values x such that x does not equal 5, because 5 would zero out the denominator. We can also see that the numerator factors, and so we can actually simplify this expression here. We can factor it the numerator into x minus 5 times x plus 3, and then with the denominator of x minus 5, the x minus 5 divides out. And so f of x turns out to be x plus 3 as long as x itself is not equal to 5. And we can now graph this function. Y equals x plus 3 has a y-intercept of 0, 3 and a slope of 1, and so points up to the right. But at the point where x is equal to 5, we don't have a function value. And so the way we're going to express that is we're going to put a hole there. If x could be 5, then what would the function value be here? We can extrapolate. We can actually see, actually that's interpolating. We can see that this would have a value of 8. And so the way we would write this situation down, that didn't work. All right, we'll try that again. The way we could write this situation down is to say the limit, LIM, as x approaches 5, that's what we're talking about here, as x approaches 5, of x squared minus 2x minus 15 over x minus 5, that limit is equal to 8. It's the value that the function would have, the y value that the function would have if it could have a value when x is equal to 5. A limit itself, it implies a two-sided situation. That is to say, when I approach 5 along the x-axis, I can approach it from the left, that was from the right, excuse me, or I can approach it from the left, right? So I can approach 5 from numbers larger than it, to the right, or I can approach 5 from numbers smaller than it, and that would be from the left. To denote that I'm talking about one side, let's say the left, the actual left, the purple one here, we would say LIM limit as x arrow 5 and a little exponent looking thing that looks like 5 to the minus, but it's 5 from the left is how we would say that, of x squared minus 2x minus 15 over x minus 5. We would say that that equals 8. And likewise, we would say that the limit as x approaches 5 from the positive side, right? So a little exponent looking plus x squared minus 2x minus 15 over x minus 5. Or I should have said the limit as x approaches 5 from the positive side of, I missed that, of x squared minus 2x minus 15 over x minus 5 is also equal to 8. Now, the deal is that if from the left and from the right I'm saying the same number, then I can say, yep, the limit is 8. And that's the concept of a limit. Now, when I tell folks that the limit of a function is what it would be if it could be, I think that some folks make an inference that's not correct. So I want to dispel a misunderstanding right away. Let's consider a function that's related to the one that we just looked at. Consider g of x is equal to x plus 3. Now, this function is what f reduced to, but see, the domain of f doesn't include negative 5. So these are functions that agree everywhere except for where x is equal to 5. And we're going to go ahead and draw that graph. And we can see that, of course, x is okay to be 5. It's not a problem. And when x is 5, the function value is 8. So we can actually say that like g of 5 is equal to 8. No big deal there. Then the question is there a limit for the function at this point here? Like, can I consider the limit as x approaches 5 of x plus 3? I'm going to pause my discussion to talk about notation just a little bit. In the previous expressions here, I was finding a limit of a fraction, right? It was a single term. Here I have multiple terms, x plus 3, and so I need to put parentheses there. I need grouping symbols there. Anyway, what would the function value be when x is 5 if it could be? Well, the answer is 8. It makes no difference whether we actually attain that value. We never care if we actually attain that value when we're thinking about a limit. We're going to care in a future lesson, but we don't care right now. So it doesn't matter if I have a hole and that hole has a y value of 8, or if I have a point and that point has a y value of 8. The limit is the same thing, because as I approach 5 from the right and from the left, the function value is approaching 8 from, in this case, the top and from the bottom. All right, and I can illustrate that in the previous example as well. As I approach 5 from the right with the blue arrow, and as I approach 5 from the left with the purple arrow, the function value is zeroing in on 8. And in this case, it's from above and from below. That there is the concept of a limit, and it's the basis of calculus. Calculus is the study of limits and their implications as far as I'm concerned. And so everything that happens in calculus is a result of this concept of a limit.